So this is an example circuit for applying mesh loop current method. Mesh current method. So there are three meshes or three loops here. So I have assigned three loop currents I1, I2 and I3. So we'll write the loop equations. So for the first one, this is here. So as like before, all the elements, all the resistances, 3 ohms plus 1 ohm plus 5 ohm, that will go with I1. Then this 1 ohm is common between I1 and I2, so I2 will come as a negative here, and there is nothing common with I3 there, so this first equation will not contain I3. For the second one, there is no voltage source here, so it's 0 on the left hand side. That's the EMF. Then I1 will come with as a negative, and the resistance is 1, so 1 I1. Then I2 will come with sum of all the resistances, so 1 plus 2 plus this one is 8, so 8 plus 6 I2. Then the common resistance between I2 and I3 is 8, so I3 will come like that, so it will become minus I1 plus 17 I2 minus 8 I3, and this one is becoming 9 I1 plus 9 I1 minus I2. And the third one is there is no I1 here. I2, the common is 8 ohms, so I2 will come as 8 I2 negative plus the sum of the resistances are 8 plus 9 plus 7 I3, which is minus 8 I2 plus 24 I3. So yes, I have, if I write the matrix here, this one is the coefficients are 9 for the first equation, coefficients are 9, negative 1 and 0. For the second one, the coefficient of I1 is negative 1, then 17 and minus 8 are the coefficients of I2 and I3 respectively. Similarly, for the third one, the coefficient of I1 is 0, I2 is minus 8 and I4 is 23. So the determinant form for I1 will be like this. So it will have 9 here, then negative 1 here, this is I2, the negative 1 here, and this one is 0. So this is the coefficient of I1, this is I2, this is I3. For the second equation, the coefficient of I1 is the negative 1, I2 is 17 and I3 is negative 8. For the third equation, coefficient of I1 is 0, this is negative 8 and this is 24. For the numerator, since this is I1, this is the first one, here the left hand side will come, the EMFs, and then the other two will be the same. So 0 and minus 8, 24 here. So if I solve this, this will be 10 here, negative 1, 10 here, and 17 into 24 minus 24 here, minus 8 into minus 8, which is a plus 64, so minus 64. Then minus 1, minus of minus 1, so 0 into 24, that's a 0, so it becomes 0, and then 0 into 8, that's also 0. So basically for minus 1, this is 0 into 24 minus 8 into 0, so that's a 0. For the third one, it's already a 0 because this thing is 0. Here the denominator is 9 here, so 17 into 24 minus again 64 minus of minus 1, so it becomes actually plus 1. Then 24 into minus 1 is a minus 24, and then minus 8 into 0 is 0, so that's 0, and then the third one is 0. So here only these two term I won't do the solution though, I will leave it here. So this is this one, and on the numerator it is just this term because everything else is 0, and if we solve it we will get the current I1. Similarly for I2 I will write what it will be for I2. Let me write with another color. So I2 will be like that. If it is I2, the denominator will be the same. What the change will be here, so basically for I2 this one will become 10 0 0, and this one will remain the same. This will be for I2, and similarly the denominator here will be the same, but this one will change again and we will get the I2. And for I3 it's exactly similar. So for I3 it will be, this one will be I3, and this one here will be 10 0 0, and this one will remain as same, so this one will be -1 17 -8. So that's the change. So whichever, so first we have to write them in specific order. So first I1, then I2, then I3. So here the coefficient of I3 is 0, here the coefficient of I1 is 0, and here the coefficients of I1 are like -1, then I2 is 17, and then I3 is -8. So that's what it's been written here, and we just solve it, we get the currents, respective current from that. So this example is just to illustrate the method of loop currents or mesh currents for circuit solving that I discussed, the theory I discussed in the last video. So this is just an example.